Hello friends, welcome to my channel Civil Engineering Notes Changing the Way of Learning। स्वागत है आप सबका। अब हम बात करने जा रहे हैं सिविल इंजीनियरिंग सब्जेक्ट सोयल मैकेनिक्स का पार्ट 8 लेके। यहाँ पे मैं सोयल मैकेनिक्स का कुछ थ्योरी पार्ट डिस्कशन करूँगा जो आपका कोई भी एग्ज़ाम में बहुत ही हेल्पफुल होगा। तो चलिए स्टार्ट कर रहा हूँ। एग्जिट ग्रेडियंट, द हाइड्रोलिक ग्रेडियंट प्रोवाइडेड at the downstream side of a hydraulic structure such as a dam is called exit gradient or downstream gradient or tailed water gradient. It is defined as the ratio of the head loss to the length of seepage। ये very important है। The maximum permissible exit gradient is the critical gradient divided by the factor of safety. Stress conditions in a soil. Stress condition in soil. The total stress or unit pressure at any plane in a soil mass is the total load per unit area. The total stress consisting of effective stress or intergranular pressure and neutral stress or pore water pressure. The effective stress on the soil is due to external load acting on the soil and the self weight of the soil particles. This stress is effective in decreasing the void ratio of the mass and in mobilizing the shear strength. The neutral stress or pore water pressure on the soil is due to the weight of water present in soil pores. It is transmitted to the soil base through the pore water. This stress does not have any measurable influence on the void ratio or any other mechanical property of the soil such as shearing resistance. The decrease in effective stress is accompanied by increase in the neutral stress. The effective stress is increased if the water is flowing from upward on the soil mass. The neutral stress is decreased if the water is flowing from downward on the soil mass. Compressibility and consolidation. देखिए, when a compressive load is applied to soil mass, a decrease in its volume takes place. The decrease in volume of soil mass under stress is known as compression, and the property of soil mass pertaining to its susceptibility to decrease in volume under pressure is known as compressibility. In a saturated soil mass having its voids filled with incompressible water, the decrease in volume takes place due to the expulsion of water out of the voids under an applied load. Such a compression resulting from gradual reduction of pore space under steady load is called consolidation. According to Tarjaghi, every process involving a gradual decrease of water content of a saturated soil at constant load is called a process of consolidation. In case of coarse-grained sand having high permeability and low plasticity, 95% of consolidation occurs within 1 minute and after the application of load. Coefficient of compressibility. The coefficient of compressibility is defined as the decrease in voids ratio per unit increase of pressure. If the pressure on a clay layer increases slightly from P to P plus gamma P and the voids ratio decreases from E0 to E, then the coefficient of compressibility AV is given by AV equal to E0 minus E by gamma P. For a given difference in pressure, the value of coefficient of compressibility decreases as the pressure increases. The unit of coefficient of compressibility is inverse of pressure. The change in volume of a soil per unit of initial volume due to given increase in the pressure is called the coefficient of volume changed or coefficient of volume compressibility. It is very, very important. The coefficient of volume compressibility is directly proportional to coefficient of compressibility. It decreases with the increase in pressure and the void ratio. So guys, it is much for today. अगर आप हमारा चैनल पे नया है तो चैनल को ज़रूर सब्सक्राइब कीजिए. थैंक यू.